Hey guys, we're on our last lesson, lesson 16, before we have to take our third exam. I can't believe we're already here. This third exam will be interesting because every single lesson that's on exam number 3 is a lesson that we have had to do virtually. So I'm hoping that you guys feel confident by the time you have to take it. And certainly email me if there's any concerns of any kind, but you guys have been doing really well with keeping up with things, and hopefully these videos are at least helping somewhat compared to being in class face-to-face. All right, so let's talk about lesson 16. Lesson 16 is actually one of my favorite lessons. I'm really excited about this one. And what's really cool about today is we only have to do half of lesson 16. So today we are going to do chapter 7, section 3. Now, normally when I teach lesson 16, I also have to cover 7.2. We're not going to do that today. 7.2 is basically the same type of problem that we're going to do today, these percent problems, and you'll see what I mean in a moment, what those look like. But 7.2 is solving percent problems using equations. But we're just going to focus on one method today, the easier and I think the easier and faster method, and that's using proportions to solve percent problems. Now, technically, proportions are equations. We just learned about proportions in the last week or two here. But remember, proportions are like when you have a ratio equal to another ratio, like 3/4 equals x over 12, and you have to solve by cross multiplying and then setting it up as an equation and solving it. So technically we are still using equations. I just want to point one thing out though. When you guys get to the homework, the lesson 16 homework, some of the directions will say, translate the following as an equation and then solve. Or they'll say, write as an equation and solve. You can just ignore those directions and use proportions for every single one of your homework questions. It's going to be the same type of question over and over and over, written in slightly different ways, and you can make a proportion for every single one of these problems. I'm going to try to cover, as usual, every type of situation you could possibly see. So I'll throw a couple decimals at you. I'll put a couple mixed numbers into the mix, or at least one of them today throughout this lesson. I'm also going to show you situations where we don't know the percent and situations where we do know the percent. Again, I'm going to cover every single thing that you could possibly see. So let's go ahead and get started. I think the most important thing is the setup. And so let's write that down right now. There's no definitions today. We don't have any new vocabulary words, but we do need to understand how to set every single one of these problems up, because the good news is you're going to set up every single one of these problems the same exact way. All right, so it's going to be a ratio equal to another ratio. And I know this might look a little funny. The reason why I made this one longer, you'll see in a second, is because I have to write a lot more on the top and bottom. Let's start over here on this right one. What you're going to do every time is you're going to put the percent on the top, or in the numerator of this fraction. The percent goes on top, and on the bottom is always going to be the number 100. And that should make sense because, as you might remember from a recent lesson, percents are always over 100. They mean per 100. So every single time, whatever our percent is, we're going to put that in the numerator, and 100 goes in the denominator. Now, I always like to, it's just a preference thing, I like to make this fraction with my percent in it the fraction on the right of the equal sign, but you don't have to. You totally could make it on the left and put this one on the right. I just like to maintain consistency, so you're going to notice in this lesson today, I'm going to keep doing percent over 100 as my fraction on the right side of the equal sign every single time. All right, so what goes on the left side? Well, let's start with the denominator because that's the easier part. It's actually easier to start with the denominator here because what goes down there is the number after the word of. After the word of. Okay, so whatever number comes after the word of, that's always going to go in the denominator. And I'll tell you what, you will see the word of in every single one of these homework problems. So that's good news. There's not going to be any trickiness there. And then what goes in the the denominator? What goes in the numerator is the part compared. I'm writing kind of small. The part compared to the whole. And that might not make a lot of sense. The part compared to the whole thing. Bottom line, here's the important thing you need to know here. Let's draw a little arrow. You want to fill this spot in last. Fill this spot in last. Okay? Let me see if you can read all that. Hopefully you can see what I just wrote. Okay, so the numerator on the left side is going to be the last thing you fill in. It's like whatever's left over in the problem, that goes there. Because sometimes it's confusing. The part compared to the whole, not everybody really understands what that's saying. But down here, this is very easy to understand, right? Whatever number comes after the word of, that goes here. Whatever the percent is, that goes here. 100 always goes here. So just fill this part in last every time, and I think you guys will be really good to go. Now, if you can remember the setup when you're doing these problems I think are gonna be really easy for you. So let's go ahead and do our first example. And so this is what the directions will look like in my math lab. It'll say, solve the following percent problems. Solve the following percent problems. And again, sometimes my math lab might say specifically solve using equations or translate into an equation and then solve. But again, just ignore any directions that say something about equations. Just solve all of these again as proportions using this setup, and you should be absolutely good to go. All right, example number 1 looks like this, and you've probably seen these problems before. There's so many ways to do these, but there's so many ways that I think are so much more difficult than what I'm going to show you. This is the method that hands down my students year after year seem to like the most. Okay, here we go. Example number 1. So here's the question. They're kind of like story problems, but not the nasty kind. So the question is this: what number is 35% of 60? And again, if you know how to set it up, this is super easy. So what you're gonna do is you're gonna go fraction equals fraction. And all you have to do is fill in the numerator, denominator, and then solve using what we learned from about a week ago. All right, so the first things first, we have here percent over 100. So you wanna ask yourself, as you read through this question, do we know what the percent is? And the answer is, of course, yes, we know the percent. The percent is 35%. It's right there in the problem. So I'm going to put my 35 right there on top. Notice I'm not actually writing the percent symbol. That's because it ends up going away anyway in the problem, so you don't really need to write it. I would just lose it. So you just write 35 because that's the percent, and then over 100, right? Every time whatever the percent is goes over 100. Okay, then I would ask you guys this, if I was face-to-face with you, I would say, all right, try to find the word of in the question. The word of is so important. I'm putting a little star above it, right? Of, very important. What number comes after the word of? In this case, 60. Okay, so we know it's a 60. So that goes right here on the bottom or in the denominator of the fraction on the left, right? The number after the word of goes right down there. So then what number goes up here on the top, the leftovers, the part compared to the whole? Well, in this case, if you look through this question, there's no more numbers in the question. We've used them all up. But look what we do have. This right here. What number? What number? That means the same thing as X or whatever letter you want to pick. That's your variable. So anytime it says what or what number, that's going to be your X. So in this case, that is our leftovers, and that goes on top of our left fraction. And so now we've just completed the setup of our first example. So hopefully you didn't think it was that bad, but the more we do of these, I think you're going to be like, oh my gosh, these are so easy. They're not that bad once you do a bunch of them. But let's go ahead and solve this. You might remember how we solve it. We have to multiply the diagonals and set them equal to each other. So what we end up getting now is 100x. So you get 100 times x, 100x equals, and then you multiply the other diagonal, 60 times 35. Now again, if you would have written 35 times 60, is that okay? Absolutely. Order does not matter when you're multiplying two things, so you're totally allowed to write it in whatever order you want. It's not going to be wrong either way. All right, so there you go. I'm going to make my bridge. I'm going to bring down my 100x for my first step, and I'm just going to take my calculator at this point, and I'm just going to type in 60 times 35. 60 times 35. By the way, if you don't have your calculator handy throughout this lesson, I would definitely get that out right now because we're going to use it quite a bit. You can do these by hand, but it's so much easier using a calculator. Okay, so 60 times 35 is 2,100 and that's it, 2,100. Okay, then we have to get rid of this 100 that's attached to our x. And so the only way to get rid of a 100 when it's 100 times x is to divide. Divide by 100, cancel, and so x equals whatever 2,100 divided by 100 is. And so again, you could use your calculator, type it in, hit equals, and you get 21 for your final answer. And that is the correct answer, 21. If you have time when you're taking your exam number 3, maybe not so much for the homework because it's not as important, plus you can retry problems, but when you take exam 3 and you get to this section where you have to do these problems, if you have time, maybe take your answer and plug it back into your proportion and check to make sure you have a true proportion. Remember, we learned that phrase recently as well. A true proportion is when you take your answer, you plug it in, 21 over 60, and you just multiply the diagonals, and if you get the same number, 2,100, 2,100, going both ways, then that means you have a true proportion. That also means your answer is correct. So again, if you have time, it's a great way to check yourself. But there we go. We just completed our first percent problem using proportions. All right, so let's do a few more. Okay, so you could see things kind of written in different ways. So let me show you something very similar to the one we just did, very similar, but it's going to be written a little bit differently. So example number 2, what if you have something written in this way? They start off, the very first part of the sentence is the percent. 85% of 300 is what number? All right, 85% of 300 is what number? All right, so again, you're gonna set it up. Fraction equals fraction, we're making a proportion. And you wanna always start by asking yourself, do I know the percent? Yes, I do. The percent is 85. So that goes right on the top of the fraction on the right. So 85, and it's always over 100, right? Percent over 100. So 85 over 100. Okay, the next question I would ask you is this. Can you locate the word of? Yes, right here. Very important word, of. What number comes directly after the word of? 300. And so you guys might remember, according to our setup, that number, 300, goes right there on the bottom of the fraction on the left. And so, again, what are my leftovers? What's the part compared to the whole? Well, right here, again, I messed up my, I'm so bad at brackets. I'm not even gonna try again. It just looks like a mustache. Okay, so what number, we don't know the number, but remember, if you see the word what or what number, that means that's your variable. So pick any variable you want. I'm gonna pick X every time just to keep it simple. What number means X, and so that's gonna go right there, and you have to solve for X. All right, so when we do that, again, when we multiply the diagonals there, you're gonna get 100x, because it's 100 times x, equals whatever 85 times 300 is. 85 times 300, or 300 times 85, same thing, you'll get the same answer. All right, I'm gonna bring down my 100x, and then at this time I would take my calculator and go 300 times 85, and I get 25,500. 25,500. All right, and then my very last step is just to divide by whatever number is attached to x. So again, we're gonna divide by 100. Divide by 100. You might be able to do this in your head. We did learn a few weeks back that if you're dividing, actually no, I guess we only learned multiplying by 10, 100, 1,000, or multiplying by 0.1, 0.01, 0.001, right? When you're doing things like that. So, I mean, you might need a calculator, but this one comes out nice and even 255, right? All right, 255, final answer for that one. Again, you can check your answer by plugging it back in to your original proportion and making sure that you get a true proportion. All right, so our answer was x equals 225. So very good. So I'm sorry, 255. Oh my goodness, I'm talking all over the place today. I apologize, guys. I'm saying the wrong thing. 255 is our final answer. I did say 225 on accident. Okay, example number 3. Example number 3. How about one like this? 12% of what number is 0.6? Okay, so for this one, I put a decimal in the problem, but that really doesn't make it any harder, especially if you're using a calculator. But you might be thinking, didn't we just do an example exactly like that? We started off with a percent, and kind of, we did. We started off with a percent, but look what happens after that. In our previous example, it said of and then a number. This one says of what number? So this one's actually going to be significantly different. So let's go ahead and set up our fraction equals fraction. In other words, let's set up our proportion. And so again, I'm going to ask you guys, do you see a percentage? Yes, right here. So that's going to go on the top of the fraction on the right, 12. And always that percent is over 100. So there we go. Our fraction on the right is 12 over 100. And then here's where it gets a little different. Look at the word of. It's right there. What number comes after the word of? Well, it's not a number. It's what number. And so what did we say a moment ago that translates to? That turns into a variable. Any variable you want. Again, x. I will choose x every time. So remember, whatever comes after the word of goes on the bottom of the fraction on the left here. So that x is actually on the bottom this time. So we have to be really careful. And then the word here, in this case, it comes after is, but that's not anything we're really looking for. That number is our leftover number, and that number is going to go right on top as the numerator of our fraction on the left. All right, so this one has a little bit of a different setup from the other one. Now again, remember, this is a preference thing, but what I personally like to do is I always like to start with the diagonal that has the x in it, because I like my x to be on the left side of my equation. It doesn't mean you have to do it this way, but just for consistency, I will always do it this way. So I'm going to do x times 12, or 12 times x. That turns into 12x. And then, of course, we're going to multiply the other diagonal, which is 0.6 times 100. 0.6 times 100. And so this is what our proportion turns into as an equation. So I'm going to bring down the 12x to solve this. And now I may or may not need a calculator for this one, because remember, this is one that we did do an example of, where if you're multiplying by 100, there's 2 zeros. So you could just simply move the decimal 2 places to the right, or you could use a calculator. Either way, you get 60, right? 12x equals 60. And then you have just one final step. Get rid of that 12 by dividing. Can't have a 12 attached to x in your final answer. And so 60 divided by 12 is a nice even 5. By the way, you guys know this, but I'll mention it again. If you see in my math lab some directions that tell you you have to round a certain way, of course, you're going to need to do that. Or if they say leave your answer as a certain kind of fraction or a mixed number, improper, proper fraction, make sure you just follow whatever the directions say, as always. Our numbers happen to be coming out really nice today. They may not always, but I will tell you for this particular homework, almost all of your answers, if not all of them, should come out to really nice numbers. You shouldn't get anything nasty. But again, if they do tell you to round, you need to make sure that you're rounding. All right, so that was example 3. Let's do example 4. Let's talk about example 4. Again, each one of these is going to have something just slightly different than the other ones that we're doing. So, all right, example number 4 looks like this. 13 is, now notice it doesn't say 13%. 13 is 2.5% of what number? Of what number? Okay, 13 is 2.5% of what number? All right, so there's a few options here for what you may want to do. Some people look at this 2.5% and they say, well, 2.5 is kind of an easy number to translate into a decimal. And they might say, well, I know that 2.5 is 2.5, so I'm just going to rewrite this as 2.5. Other people might say, you know what, I'm just going to write this as an improper fraction. And they would say 2 times 2 is 4, plus 1 is 5, and they would like to write this as 5/2. And then they can just put it in their calculator as 5ABC2. Or some people might just leave it as a mixed number and say, I'll just put it in my calculator, 2ABC, 1ABC2, and I can just put the mixed number directly in. There is no right or wrong answer, of course. You can do it however you want, whatever's easier for you, whichever method you might prefer. So what I'm going to do, I think what I'm going to do is just say, well, I know that's the same thing as 2.5. And if you're wondering how I got that, remember in the lesson that we had recently where we convert percents into decimals or fractions and mixed numbers into decimals and vice versa, and we did all that converting. We said, okay, if you have a mixed number situation and you're trying to convert that into a decimal, what you can do is take the whole number part, which is 2, okay, and just bring it up. We know that the whole number part stays the same, 2, 2. So all you have to do is take the fraction and change that into a decimal. And how we do that is just dividing top by bottom. Numerator divided by denominator. 1 divided by 2. You could do it by hand or on the calculator. Either way, you get 0.5. All right, so I'm going to keep this as 2.5%. Technically, this is still a percent. I didn't convert the percent part. If I wanted to convert this whole thing into just a decimal, remember, I would have to move the decimal over 2 places. 2 places, in this case, to the left to make it into a decimal, going from a percent into a decimal. But we don't want to do that because we want to leave it as a percent because our setup for these problems involves a percent. As a matter of fact, let's do that right now. The very first thing that we're going to put on the top of this fraction is a percent. And so I'm going to go ahead and put this 2.5 right on top, 2.5, and then again, as always, over 100, always over 100. All right, so 2.5 over 100. Again, if any of you left it as 2.5, or if any of you wrote it as 5 halves and you put that here, all of those are perfectly good, fine things to put there. So don't think that this is a better way. It's not. I just like decimals better than fractions, but you can totally use whatever method you like. All right, so again, you want to look for the word of. It's right here. Here's the word of. What comes right after the word of? Well, there it is again, the phrase, what number? So that's my x. And so that goes on the bottom of the fraction. Whatever comes after the word of goes on the bottom. And so then what's my leftover number? Right here, this 13. That's the part compared to the whole. It's also my leftover, the last number that I didn't use. So that goes on top. All right, so now I'm going to convert this into an equation and solve. So I always like to start with my x diagonal. So this turns into 2.5x equals 13 times 100, right? This diagonal being multiplied now. Okay, so there we go. So we get this. Now I'm going to bring down my 2.5x equals, and I may or may not need a calculator here, 13 times 100 is 1,300 or 1,300. So you get this. Then you have to get rid of that 2.5. It is attached to the x by multiplication. So we're going to divide 2.5 and we get x equals 1,300. I'll just use my calculator. 1,300 divided by 2.5 and I get 520. All right, so you get a 520 for your final answer for that one. That is the correct answer. And that's all you have to do there. Again, you can check yourself if you want or if you have time. If it's an exam question, it's a good idea. All right, there's example 4. Let's do 2 more examples before I just throw a couple real life examples at you. I always like to try to relate math to real life whenever we can because it's kind of rare when it happens. And I mean that because you learn so much in all these math courses that you take, and so many times students are left wondering, when are we ever going to use this? What's the point of this? Or is it just to get my degree? And a lot of times the honest answer is, you know what? You just have to know this so that you can take the next course and take the next course and get those credits and get your degree. And so I love lessons where we can actually have some real life examples. So I'm real excited. We're going to get to those in just a minute. Right after example number 6, I'll get to a few real life examples and then we'll close. So here's example 5. What percent of 12 is 9? Sorry about that is. That looks kind of messy. Okay. What percent of 12 is 9? Okay. Now I'm going to pick up the pace just a little, but I don't want to go too fast because we haven't done a problem yet where we have to find the percent. But I'm going to go just a little faster because some of you might be like, okay, we get it. We've done a few of these. I can go a little faster. So let me start with this question. What is the percent? Well, so far, every single example we've done so far, they've given us the percent. We had a number to write right here on the top of this fraction. But in this particular example, we don't know the percent. Oh my goodness, I'm having trouble again. I do not know what's wrong with me. I can't make braces right now. Okay, well, we'll go with it. So what percent? Oh, I know why. I started high. I needed to start like this. Yeah, there we go. I started, okay. Well, anyway, okay. So what percent is going to be my x? Okay, that's my x or whatever my variable is. So that goes on top right here of this particular fraction. And then what goes under it? As always, 100. Okay, this is our first example though where we don't have a number above the 100. We have an x. Okay, here's my next really important question. Where's the word of? Right there. There's my word of. What comes directly after the word of? 12. Where does the number that comes right after the word of go? On the bottom of the fraction on the left, right there, 12. So then what's my leftovers? What's my part compared to the whole? 9. That goes on top. Whatever's left over. Remember, that's the last number you want to put in your proportion because it's kind of the hardest one to figure out where it goes. All right, so we set it up. Let's solve. X times 12 is 12x equals 9 times 100. I think we can all do that one in our head, which is nice, right? 9 times 100 is 900, okay? So 900. And then your last step is to get rid of that 12 attached to the x. Divide by 12, and you get x equals 900 divided by 12, which comes out to a nice 75. Okay, there we go. So x equals 75. Final answer for that one. Have you guys noticed by now, you probably have, that when you're doing all of these proportions, it's always like some number times x equals number times number, and then you always clean up that side, and then you're always dividing by something last, and you get the answer. It's the same pattern over and over, which is very cool. When you get to this homework, it might be a little bit annoying at times, but it's so cool that there's like this setup and this formula, and it works the same way every time. So I think you guys might have a real easy time with this. Once you get through like the first few problems, you'll be like, oh, this is not bad. And you'll maybe even like doing these problems a little bit. And when you get to the exam, you might be excited to do these problems because they're not terrible. Okay, example number 6. How about this one? 78 is what percent of 65? This one is very similar to the last one, right? Because again, you're going to see that phrase, what percent? That should be an indicator to you that means we have to find the percent. We're not going to know the percent in this problem. So let's do our setup. Fraction equals fraction. Okay, what is my percent? We do not know. My percent, see if I can, look at that, not bad. All right, so what is my percent? My percent is something we don't know. It's what we need to figure out. So what percent gets an X? Oh, I just thought of something. Oh, major important thing here. Let me go back. Oh my goodness, example number 5. The question was what percent of 12 is 9? And even though that's correct, because the question says what percent, we want to make sure if we have to find the percent, we want to put the percent symbol in our answer. If they ask you what percent, then you need to label your final answer with percent. That's actually pretty important. Now, I think my math lab will set up all of these problems for you by putting the percent in the as part of your answer. Like it'll look like this. It'll go like X. Actually, they probably won't even have an X. It'll probably just be a box, and then it probably says percent right after it if it's a percent problem. But if not, if they don't have that there, you need to make sure you remember, unlike me, I totally I missed the bar on that one. You want to make sure you put that 75 with a percent symbol in the box if they don't have a percent symbol for you. But remember, guys, you only do that on problems where it says what percent. Okay, if it doesn't say that, don't write percent. Okay, so totally missed that last one. So my apologies, goodness gracious. This is like one of my favorite lessons and I've made like 7 mistakes so far. Hopefully you're still watching this video and not giving up on me. But thank you for your patience. You guys have always been so good to me about it. I make a lot of mistakes. Okay, so how about this? 78 is what percent of 65? Back to this. We already said we don't know the percent. So that goes right there on the top. Always over 100, whatever the percent is, over 100. All right, where's the word of? Right there. What comes after the word of? 65. So that number right there goes on the bottom of the fraction, always on the bottom, and your leftover number goes on the top, 78. The part compared to the whole, 78. All right, so now when we go ahead and multiply, cross multiply to solve this proportion, we get 65x equals 78 times 100. Okay, 78 times 100. All right, so I'm gonna make my bridge, bring down my 65x equals 78 times 100 is super easy, right? 7,800 or 7,800. We can do that in our head. Not too bad. And so now your last step is, of course, divide by 65, divide by 65. So x equals, I would definitely use a calculator here, 7,800 divided by 65, and look what you get, 120. And remember, this one said what percent? So that's why I'm putting a percent in my answer. Okay, so my final answer is 120%. Now we talked about this in our last lesson, how percentages can sometimes be over 100. In this case, it is over 100 a little bit. And that should make sense actually, because if you look at the question, it says 78 is what percent of 65? Well, it's kind of a weird question because 78 is bigger than 65. So if you say 78 is what percent of 65, and it's more than 65, then that means the answer has to be more than 100%. And that's a good way to kind of check yourself. And you're like, oh, I probably did it right then because my answer is a little bit over 100%. So that makes sense. All right, great. Yeah, it's always a good idea to ask yourself if something makes sense. All right, so here's what I'm gonna do for the remainder of this video. If you feel at this point like, you understand this really well, this makes sense, you're ready to tackle the homework, feel free, of course, to chop the video off now. But if you would like a couple more examples, if you're like, yeah, I could use just a little bit more, I wouldn't mind seeing it. Or if it's interesting to you to see some real life examples, real world connections to these types of problems, which really excite me, because again, it's not every day that you can use the math we learn in real life, but here we can. So if you're interested, I would say hang on. We're gonna do just 4 more very quick examples. I'm gonna go even a little faster because now we know what we're doing. And I'm just gonna kind of verbally talk you through some scenarios and then write it as a question. So here's what I'll do. Let me do a fresh sheet of paper if you want to kind of copy this, or you can just kind of watch. I'll call these real world scenarios. Okay, real world scenarios. Now again, I'm not going to write out all of it. I'm not going to write it out as one giant story problem. So maybe just kind of listen. I'll kind of give you some examples as a story problem verbally, and then I'll write it out as a question. So here's our first real world scenario. Let's say you are really into budgeting, and hopefully you are. Most people do better when they budget. I'm terrible at it, but it's such a good thing to do if you can. Let's say you enjoy budgeting, you like keeping track of your money every month and just kind of seeing how you're doing. And let's say you have a credit card that gives you 1.5% cash back. This happens in real life a lot, right? There's a lot of credit cards out there that give you 1% cash back or 1.5% or even 2% cash back on everything. Some credit cards give you 5% on certain purchases. So there's all kinds of things out there with credit cards. But let's say you have a credit card that gives you 1.5% cash back on everything. And let's say over the course of one particular month, you spend $1,462. Okay, so I'll just write out some of these details. Let's say you spend $1,462, but you get 1.5% cash back on your credit card. And so let's say you're kind of budgeting things and you're like, well, how much does that mean I'm gonna get back in cash this month if I've spent this much on a credit card that gives me this percent back? Well, here's how you could write it as a question. You could say 1.5% of 1,462 is what number? Okay, so see how we can take a real life situation and write it as a percent problem. And now we're gonna use a proportion to solve it. So cool. So if you're ever in this kind of situation, you can totally make a proportion and solve it, and you'll be able to figure out exactly how much cash back you're gonna get in a month. So I'm gonna go kind of quick. The percent is 1.5 over 100. Here's the word of. What comes after of? 1,462. So that goes on the bottom, whatever comes after of. And then the leftover thing here, what number? That's my x. That goes right on top. And so now to solve it, cross multiply. X times 100, that's 100x, right? Equals 1,462 times 1.5. All right, so now I'm gonna bring my 100x down, equals, and I'm gonna go 1,462 times 1.5, 2193. 2193, that's what you get. And then of course, divide by 100, divide by 100, x equals, when you divide by 100, if you just want a little shortcut and use your head, and instead of a calculator, mentally you can just say, if you're dividing by 100, you just move your decimal 2 to the left. So you go boom, boom, and your final answer is 21.93. So in this case of a real life scenario where you would spend this much money on a particular credit card, but you get this much cash back, that means at the end of the month, you would get $21.93 back on your credit card or cash or however you opt to do it. Sometimes people give you gift cards, companies give you gift cards. But whatever the case, that number makes sense, doesn't it? Doesn't that number kind of make sense? And you want to always ask yourself that when you do these problems. Does that number make sense, that if I spend this much and I get 1% cash back, that I would get a check for about that much? Yeah, that makes sense. Because what if your answer was, let's say you forgot to move the decimal or you forgot to divide by 100. What if your final answer was 2,193? You ask yourself, does that number make sense? Well, no, not at all. It doesn't make any sense that you would spend this much and get even more back in cash. To get $2,193 back makes no sense. So at the end of the problem, you always want to ask yourself, does my answer make sense? And if it does make sense, that's a good indication that you probably set up your proportion right and solved it correctly. If it's like an outlandish answer, if it's just nonsensical, then you can say, you know what, I probably set up my proportion wrong. I should redo the problem. Now, I didn't put a $ in this answer because my question was just 1.5% of 1462 is what number? So I didn't put a $ in my answer. But if this was actually a story problem involving money, then yeah, I would put a $ there. But I didn't want to put it in the answer because you don't have to do any story problems in this lesson 16 homework. There's no story problems. So I just didn't want you to think that you have to like label anything at the end. The only thing you could possibly have to label is putting that % symbol in your answer. So do not worry, you have no story problems that you have to deal with. The only reason why I'm showing you these again is because they excite me, because I love when math in our class relates to real life. Okay, let's do just a little bit more of the real life scenarios because I do think these are really cool. I think they're good to see. All right, in this next example, let's take Giant Eagle or Market District. I guess some of the stores now call themselves Market District. Let's take them for example. Okay, Giant Eagle, and there's many grocery stores that offer all kinds of deals. But you may be familiar, some of you may shop at Giant Eagle or Market District, and you may be familiar with the fact that they have this 20% off reward system. And it's very cool. It's this thing where, you know, you work your way up to getting 20% off your grocery order. You have to spend a total of $500 over the course of months, and then, you know, whatever, and then you work your way up to getting this 20% award off any purchase that you want. And so let's say again that you're kind of budgeting your money and you're kind of, you know, thinking about things for a particular month. And let's say you have built up 20% off. So that means if you have 20% off, I'm just going to write a couple details here, means means you pay 80%, right? Okay, 20% off means you pay 80%. If you're getting 20% off, okay, that's 100% minus 20. That means you're paying 80%. So let's say you only have to pay 80% of your groceries because you have this cool deal. But let's say that you're budgeting $350 in the budget for groceries for a month. For a month's groceries. Okay, so again, you don't have to write this stuff down, I'm just giving you some details. Let's say you're like, okay, I can only afford to spend $350 this month at Giant Eagle for my groceries. Well, you probably want to go then only one time so you can use that 20% off thing. And then you want to maybe figure out before you leave this question right here, this majorly important question. 350 is 80% of what number? Okay, see, that's the question that we get from the story problem. 350, in this case it was dollars. 350 is 80% of what number? So in other words, how much can I actually spend at Giant Eagle without going over having to pay 350? So let's figure this out. This is very cool. So proportion, and you say, okay, 80%, right? 80 goes on top, 100 goes on the bottom. We know our percentage. What comes after the word of? Right here, what number? X. So that's going to go on the bottom. And then this leftover number here, 350, is on top. So now when I solve, I'm going to do my X diagonal first. I get 80X equals 350 times 100 for my other diagonal. Okay, I make my bridge. I say, okay, 80X equals 350 times 100. That's just 35000. 35,000 is what you get there. And then divide by 80. Whoops, sorry. Divide by 80. Equals, and you probably need a calculator, 35,000, I know I do. Divided by 80, and you get 437.5, or 0.5 if you want to put a zero there. If this was a problem involving money, you would probably put a zero there for 50 cents and put a dollar sign. But again, the question didn't have any money involved. The way I wrote the question had no money, so we'll just leave it like that. But isn't that cool? Does that answer make sense? That if you only had to pay 80% of your groceries and you had $350 available in the bank to spend, does it make sense then that you could go to Giant Eagle and spend $437.50 on a one-time shopping spree, but only have to pay $350? And the answer is yes, because you had that 20% off. That number isn't too crazy. If you would have gotten like $4,375, let's say you got $4,375, that makes no sense. That would be too good to be true, right? That you could get $4,375 worth of groceries and only have to pay $350. That's way too good to be true. But this makes sense, and this is actually a real life example. You could you could buy $437.50 worth of groceries, but again, you only have to pay this much because you get that 20% off. So again, just kind of a cool real life example. And let me just give you maybe one more, maybe two more, I don't know. Again, feel free, you can always chop these videos off. I'll never know, it won't offend me. It wouldn't offend me anyway, but here we go. What about buying a house? A couple of you, since this whole coronavirus thing has gone down, a couple of you have actually purchased homes in this process, or even moved in over the course of this time where we're kind of quarantined. And so maybe you've just gone through this, which is very cool. Buying a house is a very exciting time, but let's say you want to try to avoid that PMI, that private mortgage insurance. You want to try to avoid having to pay a higher interest rate. So it's real important to you that you put 20% down as a down payment on a house. Now that's hard to do. 20% is a lot, but let's say you've been saving for years and years, and you have 20% that you can put down on a house. And let's say that in the bank, you have saved over these years $22,800. You saved that much money to make as a down payment. So now the question is, well, how high can you go on an offer on a house with this money if you want to put 20% down. You know, it's like, well, can I afford a $60,000 house? Can I afford a $100,000 house? Can I afford a $150,000 house? That's the question. What can I afford? So you've got 20% you want to put down. You've got this money saved. So here's how you would write it as a question. You would say 20% of what number is 22,800? That's how you would write this real life thing as a percent problem. Here's how you would write it as a question. So let's go ahead and fill in our missing pieces. Do we know the percent? Yes, 20. Cool. Over 100, right? 20 over 100. That part's easy. Then here's our word of. What comes directly after of? What number? So our variable, okay, goes down there on the bottom. The leftover number goes on the top. Okay, so 22,800. So again, we're going to go ahead and cross multiply. So when we make our equation, it turns into 20x. 20x equals 22,800 times 100, right? 22,800 times 100, you get that. Bring the 20x down, equals, this is going to be a big number here, 2280000. So you actually get 2,280,000, but that number's about to change because, of course, we have to divide by 20, right? Divide by 20. So x equals, here's where I would use a calculator, 2280000 divided by 20. Just enter it very carefully, and your final answer is 114,000. Final answer. So does this answer make sense? Does that seem like a reasonable answer? And we did do it correctly. That is the correct answer. But that number is also a number that makes sense, because think about it. If you had this much money saved and you wanted that to be 20% of the house, doesn't it make sense that you could make an offer as high as $114,000 then on a house? That number is not crazy. That makes sense, yes. Now, if you would have gotten an answer like 1,000, that doesn't make any sense because you have more than that saved. If you would have gotten an answer like 11,400, that doesn't make sense either, because certainly you can afford more than that on a house if you have this much saved. So those answers wouldn't make sense. It also wouldn't make sense to go the other way. What if your answer was 1,114,000? That answer doesn't make any sense either, because to have this much money saved and make that 20% of the house, that's not going to get you a house over $1 million. That's a very high number. So this answer makes sense, and we did do it correctly. And so that's how you could figure it out in real life. And so let's just do one more. Let's just do one more, because we didn't do any real life examples where you have to figure out the percent. So this will be the last one. Let's say you're taking an exam in whatever class, and you're pretty sure you got 28 out of 32 right. Like, you're feeling good. You took this exam. You left the room and you feel like, I felt really good about 28 of those 32 questions. There was only 4 I was a little shaky on. And so the question you want to ask yourself is, okay, so what percentage, what kind of grade can I expect to get? Did I at least get an A? Did I at least get a B? Did I at least get a C? I don't know. So here's how you could write it. You could say 28 is what percent of 32? 28 is what percent of 32? And so you could set this up very quickly. Well, we don't know the percent, right? Oop, I'm having troubles again. Troubles with the braces. Okay, so there we go. So what percent is the X? That goes on top, over 100. That goes on the bottom. And so then what comes after the word of? 32. That goes on the bottom. 28's the leftovers. That goes on the top. And so now we're ready to set up our equation. X times 32, cross multiply. 32x equals 28 times 100. You get this. I'm gonna have to write kind of small here. You get 32x equals 2,800, and then you divide by 32, divide by 32, and your final answer is x equals, I'll use my calculator, 2,800 divided by 32, and I get 87.5. And that is not only the correct answer, but it makes sense, right? Doesn't it make sense that if you took some sort of exam that had 32 questions on it, and let's say you got 4 of them wrong, Doesn't it make sense that you get like a B plus? Yeah, that's a good answer. Again, if you would have gotten an answer like 8.7%, it's like, no, you definitely did something wrong because you didn't get that bad of an F. I mean, that's doing a really good job up here, right? So that wouldn't make sense. And it also wouldn't make sense if this answer was over 100, because clearly you can't get over 100 if you're getting less than the total number of questions right. So again, always ask yourself when you're doing all of these problems, even though you're not going to have any story problems, always ask yourself, does this answer make sense? When I read the question, does my answer make sense for what the question is asking? Okay, so I'm going to leave you there, guys. I wish we could have been in person for this lesson because this lesson is so fun for me, and we could have done some cool interactive things, and I even had a Kahoot quiz for you guys to take. I don't know if you've ever heard of Kahoot, but it's this really fun, I think it's fun, where you take quizzes and you can, come up with your own username, and you take quizzes just kind of using your cell phone, and I could have projected it on the screen, and I don't know. I just had a fun little thing planned, but it is what it is, and we're making the best of it, and you guys are doing great, and I'm proud of you, and don't hesitate to email. Thank you for those of you who have been in touch with any questions and concerns that you've had. I always appreciate it. And I hope you guys are all continuing to stay healthy. And I wish I could see you. I really wish I could see you guys on exam day. That's going to be hard for me because it's usually a really celebratory day when I get to tell people you passed the class and go home and celebrate. But I guess I'll have to do that over email. All right, well, we'll make do. So, all right, until next time, we only have one more video left, lesson 18. I cannot believe it. So crazy. All right, that's a wrap. I'm going to end this. I'll talk to you guys soon. Stay safe.